Hello everyone, welcome to this lecture series on OCI block volume service. Before we dive deeper into block volume and local NVMe storage, let's look at the gamut of storage services supported across OCI platform. So starting with on the left hand side, if you see in this table, we have local NVMe, we have block volumes, file storage, object storage, and archive storage. So this is the whole gamut of storage services supported by the platform. Why do we have so many services? Well, these are tied to the use cases or the requirements customers have, and each of them have specific use cases and specific characteristics. So let's look into this really quickly. Uh, Local NVMe is NVMe SSD based temporary storage. What this means is, sorry, let me get back to the slide. What it means is it's non-persistent storage, but does survive reboots because if you're running, let's say, a database, you want to reboot the database, so it does support that. But the key point here is it's non-persistent because it's temporary storage. The capacity can be in terabytes, and you can see some numbers here for virtual machines or bare metal instances. And the use cases are applications which require a lot of throughput. So like big data applications, OLTP, where you require a massive amount of very fast storage, lots of IOPS, lots of throughput, very fast storage. Local storage, you don't want to go onto the network, you would use local NVMe. Block volume is also NVMe SSD based block storage. But in case of block volume, the difference between local and block is block volume is durable. What does that mean? That sorry, Durable means that we make multiple copies of the volumes in an AD. So even if a volume dies, we make three copies. So we guarantee that durability. The capacity can be in petabytes, much more than the capacities supported by local NVMe. And you can see some numbers right here. And the use case here would be applications that require SAN like features. So whether it's Oracle database, if you're running VMware or Exchange or any of these other applications which really require SAN like performance. The third storage service supported on OCI is the file storage. This is an NFS v3 compatible file system. Again, it's a durable storage, multiple copies in an availability domain. The capacity is exabytes, and you can see some numbers here. And this is for applications that require a shared file system. So for Oracle, it would be Oracle own applications like EBS. It can be HPC. It can be some other scenarios. And then the last two storage services are sort of you can think about those as storage for the web, right? So if you have a lot of unstructured data, you would store them in object storage. Highly durable. We maintain multiple copies in the data centers, across the data centers in a multi-AD region. Capacity is petabytes, and you can see some of the numbers here. And then, as I said, this is good for unstructured data. Archive storage is a class within object storage, and it's suited for long-term archival and backup. Again, highly durable, and the use cases for applications that require for applications that have a need for long-term archival and backups. Okay, so let's move and talk a little bit about local NVMe storage. So in this section, we are going to cover local NVMe storage, and in the next module, we are going to talk about block volumes. So what do we mean by local NVMe storage? In OCI, in some instances, have locally attached NVMe devices, and what this means is if you have applications that have very high storage performance requirements, lots of throughput, lots of IOPS, local storage, you don't want to go through network, you would use these local NVMe devices. As you can imagine, these are locally attached SSDs, and they are not protected in any way through RAID or snapshots or backup out of the box. So we don't guarantee any protection out of the box, which means that you as customers are responsible for the durability of data on these local SSDs. And you can see some instances here that support local SSDs, right? BM bare metal dense IO shape, some of the virtual machine dense IO shapes, and you can see the sizes we support, right? Going from 51 terabytes all the way come down to something like 6.4 terabyte for the smallest shape. So again, depending on your use case, you could either go with a bigger shape or a smaller shape. And if you go log into one of these SSH into one of these instances and list all the block devices, so you say ls blk list all the block devices, you can see the block the NVMe devices appear here, right? You can get a list. So rather straightforward. Now one thing which is important and you need to consider is these, like we said, these devices are not protected by us out of the box. So how do you go ahead and protect these devices, right? You can always configure RAID on these NVMe local NVMe devices. So there are various options. I'm just presenting three of them here, but you can do something other than these three options as well. The simplest is RAID 1, which is basically just a copy or a mirror of set of data on two or more disks, right? So you have disk 0 and disk 1, and the same data is just copied across these two different disks, right? The disadvantage here is there is no parity. As you know, parity is a calculated value used to reconstruct data after a failure. So if both the disks fail, there is no redundancy which is built in. RAID 10 stripes data across multiple mirrored pairs. So if you can see here, its RAID 10 is a combination of sort of two different RAID 1 pairs. As long as one disk in each mirrored pair is functional, data can still be retrieved. Right, so it provides the extra protection there. RAID 6 is block level striping with two parity blocks distributed across all member disks. So it becomes a little bit more uh, it becomes a little bit more complex. So you take a performance hit, but you get this extra durability. So again, depending on which RAID configuration you want to choose, you could go either with a RAID 1 or RAID 10 or a RAID 6. And you could try something else. But again, keep in mind that this is something which is completely your responsibility as a customer. Though we don't configure RAID out of the box, we do provide SLAs for NVMe performance. And again, if you can get these numbers from our documentation page, but you can see that going from dense IO 1.4, 2.8, 2.16, and so on and so forth, you can see the IOPS value we support, the minimum IOPS value we support. So if you go with a bare metal dense IO shape with 52 cores, we support 3 million IOPS. And again, there are some finer print you have to read. These are 4K block sizes, sort of the read-write mix for the workload, etc. Right? But there is an SLA in case you are using local NVMe devices. So with that, thanks for watching this module on local NVMe devices. In the next module, we'll introduce block volume service and we'll look into some of the details. Thank you.